guys, it's Maddie here. Today's video is going to be on empirical and molecular formulas.
So now let's discuss some of the ins and outs of chemical composition. So the questions that we have about chemical composition are these. What are the ingredients of this compound, and what are the ratio of the ingredients in this compound one to another? Well, we can look at composition by a mass perspective, that is the percentage basis on the total mass, or more appropriately by mole. So we're really interested in the composition by mole. So for instance, let's have a look at a simple scenario. We have an iron and oxygen compound. We don't know what the ratios are. We send it to the lab and we get this information back from the lab that 72.3% of the sample's mass was iron and 27.6% was oxygen. So here's the thing to do. Imagine that we had 100 grams of substance. It's not necessarily true we had 100 grams, but just imagine that we did. If that were the case, you would have then 72.3 grams of iron, and using the molar mass now of iron, you would be able to compute that there was 1.296 moles of iron in that fictitious 100 gram sample. Do the same for the oxygen and compute that there are 1.725 moles. Divide each by the smallest number, 1.296, and we get this 1 to 1.33, or if you multiply up, 3 to 4 mole ratio. So 3 moles of iron to 4 moles of oxygen, and this compound is Fe3O4. You can try it if you like, and we'll take a compound that's 50.8% zinc, 16.05% phosphorus, and 33.14% oxygen. Again, assume you have 100 grams of this sample, and you'll get 50.8 grams of zinc. Here, use the molar mass of zinc, and compute 0.777 mole of zinc. Do the same thing for the phosphorus. Use the 16.05 grams and the molar mass of phosphorus, and you will get a value here of 0.518 mole of phosphorus. Do the same thing for oxygen, and you will compute 2.07 mole. Divide each one by the smallest, which is 0.518, and we get the ratio of 1 to 1.5 to 4. That needs to be multiplied by 2, so we get all whole numbers, and you get 3 to 2 to 8. So you might think, well, is that then Zn3P2O8? Well, not exactly, but a little bit of thinking will get you that this is Zn3 and then PO42, or what we call zinc phosphate, and that's the empirical formula. So for covalent compounds, though, we need to be a bit careful. Here's a good reason why. If you have two compounds such as these two, which are ethene and hexene, they have the same mole ratio, 2 hydrogens to 1 carbon with each other, but they're clearly not the same compound. So when we're dealing with covalent compounds, we have to take it a little step further and move from the empirical formula to this thing called a molecular formula, which may be a multiple of the empirical formula. So let's have a look. Here's a gas that's 33% silicon by mass and 67% fluorine by mass. And we know that its density is 7.6 grams per liter. The question is, what's the gas? So we do the analysis you saw above for the empirical formula, do the same thing again. So here we have the silicon, molar mass of silicon. We get this not quite yet. We'll do the fluorine first. And if you do the numbers here, you get 1.178 moles of the silicon and 3.526 of the fluorine. Divide both by the smaller one, and they're in a 1 to 3 ratio. So is the gas silicon trifluoride? Well, that's certainly the empirical formula. So now we check. The molar mass of silicon trifluoride is 85 grams per mole, and we'll just get the given density of our gas and work out its molar mass. There's the density, use the standard molar volume here, check that the grams per mole come out, and this compound has a molar mass of 170 grams per mole. So it's pretty clear that our gas is just half the one we're looking for, and we just multiply by 2, so SiF3 becomes Si2F6, which has now the correct molar mass and still the correct mole ratio. And that's what we call the molecular formula. So that's empirical and molecular formulas. Thanks everyone, and see you soon. Have a look at the next 2 videos in this playlist for more on the topic, and stay tuned for our next lesson, lesson 14, hydrates.
This is my dad's YouTube channel. It's awesome. So like, comment, and subscribe!